In our lesson today, we're going to talk about lesson number 13, factors affecting reaction rates. What the big idea is, various factors can affect the rate of reaction, which means how fast a reaction can take place or how slow it can take place. Now, there are 4 factors we're going to talk about in this course that affect how fast a reaction can occur. So, what are those 4 factors? Now, if we look at the first factor, how does temperature affect reaction rate? We got to talk about the fact that when you increase or decrease temperature, you can actually change how fast a reaction will take place. So what happens here? Well, the key thing here is that when we increase temperature, this will lead to an increase in reaction rate. Now, why does that occur? Likewise, if you talk about the opposite, if you decrease, so if I write this in a different color, if you decrease temperature, you will decrease reaction rate. Now, the reason this occurs is because you got to think about reactions is collision of particles. If you increase the temperature, what you're going to do is that you're going to increase the number of collisions that these particles will have with each other. And this is due to KMT, which leads to faster particles, which leads to more collisions. More successful collisions is the word I will use. So that's the first example. It's the most common one. How you can see this in real life is, for example, if you pour sugar into a cup of coffee, if the coffee is cold, you're not going to have the sugar fully dissolving that fast. But if you increase the temperature of that coffee, make it hot, the sugar will dissolve almost instantly. Another example is whenever you have things, for example, cooking. The higher the temperature, the faster the reaction is going to take place. Now we're going to talk about the next one, which is concentration. Concentration, first of all, is defined as how much of something is dissolved in a solution. This how much, and what that something is called, we usually call that a solute. How much solute is dissolved in solution. So you can think of it as, if you have high concentration, it means you have a lot of something dissolved in a solution. Such as, for example, if you were making Gatorade or hot chocolate from powder, if you want to make it more concentrated, you're going to add more of that powder into the water. So what happens here? As you increase concentration, you're going to increase reaction rate. Now, why does that occur? And likewise, if you decrease concentration, you're going to decrease the reaction rate. Well, if you think about it, reactions is the collision, more collision. If you have higher concentration, you have more particle. More particles means more collision. You could think of it as, if you have, for example, a very busy street with lots of, for example, cars, there's a more bigger chance of those cars colliding versus if there's just one car on the road. So more solute equals more particles, which equals more collision. Now the second to last one is, how does surface area affect reaction rate? Well, what surface area is how much area some three-dimensional object has. Well, if you look at it, let's say, for example, you have a cube. So this is my best attempt at drawing a cube. Okay? Let's say that this cube is measured as 10 by 10 by 10. What this means is this cube will have a surface area of if you remember what the surface area of a cube is, it is 6 length squared. You will get a surface area of 600 units squared. Now, if I was a particle and I was trying to react to this cube, I only really have 600 places in which this cube can react. If you think of each square unit as a place for the cube to react. So if you talk about each little tiny square, each little square is where the cube can react. Now, what if I cut this cube in half? So cut in half. If that is the case, we're going to get a rectangular prism, in which now it is, you're going to get 2 of these. So you're now going to get how much surface area? Now if you calculate this, if you look at your values, this is no longer 10. This width is now 5, but these two are still 10s. 5 and 10s. So what is the surface area of each of these rectangular prism? Well, it's now going to be, in this case, 5 times 10, which is 50. You have 50 times 2, because you have another side in the back, so that's 100. Plus 400, that's going to be, in this case, you're going to have a surface area of, in toto, so you have one side here, so you have 50 plus 50 plus 100 plus 100 plus 100, oop, not plus 100, oop, 50 times 50 plus 100 plus 100 plus 50 plus 50. So, you're going to end up with a total area, surface area for each cube as 100, 100, 400 unit squared times 2, which means you're going to have now 800 unit squared. So you just increase the amount of places for a reaction to occur by 200 units squared. So you now have more places for reaction to occur. If you keep on cutting this down, keep on cutting this down, and keep on cutting this down to, for example, just one little square, one little cube of 1 by 1 by 1, you're now going to have 6 unit square cubes, but you're going to have 1,000 of them, which means now you have 1,000 of these, so you have 6,000 unit squares. You're going to have way more space to react than if you just had one solid chunk. So what that means is if you increase surface area, you're going to increase reaction rate. Vice versa, if you decrease surface area, if you decrease, this actually should be opposite. If you decrease surface area, you're going to increase. No, if you increase surface area, you're going to increase reaction rate. If you decrease surface area, you're going to decrease reaction rate. There we go. That took a bit of thinking to actually solve. And the reason why is just because now you're going to have more surface area, more SA, equals more places for collisions to occur. So that's surface area. Our last one is going to be about catalysts. Now, what a catalyst is a type of chemical that could speed up a reaction. Now, you actually have a catalyst in your body, or many catalysts in your body. We call those enzymes. So, a catalyst is a substance used to speed up reactions. But here's what the crazy thing. It doesn't actually get used up. It does not get used up. Now, when I say used up, what I mean is that it actually gets reacted, but it gets reformed after the reaction occurs. Now, in your body, we call these enzymes. Enzymes which helps speeds up body functions. These are catalysts in your body. These are proteins that speed up reactions. So how does a catalyst work? Well, first of all, we got to understand how reactions work in more detail. A reaction occurs. So a reaction occurs when bonds break and bonds form. So not only are there collisions, you're going to need to form and break bonds. But this takes energy. It needs energy. So what does a catalyst do? A catalyst, what it does is a catalyst lowers the amount of energy needed for these bonds to form and these bonds to break. Lowers the amount of energy. And this is how a catalyst works. Now, if you want more detail, you could actually learn more about catalysts in in Chemistry 12 and first year university. As always, make sure you stay safe and healthy, and I'll see you soon.